Hello everyone. Everyone, please turn on your cameras. Yeah, good. So, how was the weekend, guys?
Yeah, it went good.
That's good. Yeah. So, I hope you would have studied the Linux notes, which I had shared earlier, right? Any problems in the Linux permissions? Like
No.
we haven't completed the chapter yet.
hmm
I'm asking till the topics which we have covered earlier. Any problem in that to understand? If you feel like, then we
No.
can do a quick recap. I have prepared a presentation as well on Linux permissions so that you would understand the skeleton on what things we are working on simultaneously. And it would be easier for me to teach the octal values as well in Linux permissions. Okay, shall we start then?
You can.
Okay, let me share my screen. So, is it visible?
Yes.
Yeah.
Yes. Okay. So, today's discussion topic would be Introduction to Linux Permissions, in which we would see what are the different types of permission, different types of users, how we are going to represent or display those permissions using symbols as well as values. So let's start. So can anyone tell me what do you mean by a permission? Anyone from you? Hello?
It will be like to grant, grant agreement to some decision.
Right, correct. So in permissions, there are two types actually. One is authentication, another is authorization. So these Linux permissions are basically, we give these permissions to files and directories. Okay. So any user who has these permissions is authorized to access these files or directories. So right now we are dealing with authorization. Okay. Everyone got my point? So there are three types of permissions: read, write, and execute. And these are to protect the files and directories from unauthorized access. So whether it is as it is multi-user operating system, so n number of users would be using it. So there shouldn't be any problem that one user is accessing files and folders or directories of different users or different groups. So as it is multi-user operating system, we have to ensure the security and privacy of each respective user. That's why this concept of permissions comes into context. And these are only applicable to files and directories. Please keep that in mind. Now let's check what are the different types of users right now in context to permissions. So first there is the owner of the file or directory. He is the one who has created it. Okay, so he has all the access. Second, there is a group owner. So it is just like set of users with similar privileges. So if I create a directory by the name Enterprising AI in Linux system, I I uploaded all the notes and video recordings. Now I want only you guys, you nine people, to have access to it, right? So what I will do is I'll form a group of you nine users, and I will assign these set of permissions to that respective group. So every one of you gets the same permissions. uh, what it does is it saves my time actually. So I don't have to individually change permissions of each 9 users. I just create a group of you all, then set those permissions and execute. Okay. And the third type of user is other. So all users who are not part of the, like, who have not created the directory as well as they are not part of that respective group come under other category. So like sometimes we have to give access to particular files for a limited number of time. So we count them, those users under other users. So we grant them permissions, they get their work done, then we remove the or revoke the permissions. Okay, so everyone is clear on types of users, group, owner, and other.
Yeah.
Okay,
Yeah.
Yes.
then we have types of permissions. So there are three types of permissions: read, write, and execute. So what read does is it has different meaning for files and directories as well. In files, for files, read allows us to read the content of the file, and with respect to directory, it allows us to check the content inside that directory. So whether there is a directory inside a directory or files inside directory, we can list down them all. And if it is a file, then we can only read the content, what's written inside. Then second permission is write. Now, write for any file, write allows us to modify or change or remove, delete, add content in a file. And for directory, it allows the user to add any file or directory or delete any file or directory. So the read, write, and execute permissions differ whether it is a file, like their meaning differs whether it is a file or a directory. Then execute. Now, execute permission is specifically for files, but it applicable on directories as well. So when a file contains a set of lines, that is a code, so we call it a program, then it becomes an executable script, right? So we can execute this program and it doesn't work what for what we have created that file. So for the program or script files, there is execute permission, and for directories, for only to access the directories, there is execute permission. So everyone clear on three types of permissions: read, write, and execute?
Yep.
Yeah.
Okay. Now
Yep.
we will check how these permissions are displayed on the command line. So first, as you can see, there is a hyphen. This indicates the file type, whether it is a file, whether it is a directory, whether it is a hard link, whether it is a soft link, what type of file it is. Then there is a set of read, write, execute, first set. Those are the read, write, execute permissions for the owner. Moving ahead, there is another set of read, write, execute. The second set is the read, write, execute permissions for the group or group owner. And at last, there is another read, write, execute permission set, which is for other user. So whenever you want to make changes, first you have to identify for which user do you want to make permission changes, whether it is owner, whether it is group or other. After that, you identify what type of permissions you want to give. And like you, if you want to add read permission or you want to remove execute permission. So this is the sequence how you're going to identify which user you want to add or give permissions, then what permissions you want to grant or revoke. Everything good till here?
Yeah.
Yeah.
Okay.
Yes.
Okay. Now this is something new. I guess we haven't done this, right? Permissions like the
Yes.
octal values decimal. Okay. So
No.
yeah. So while representing different permissions, their values, we have numerical method as well as symbolic method. Okay. So in numerical method, I want you guys to remember three important things: the decimal number for read, write, and execute permissions. Okay, so for read permission, there is a number 4 associated with. For write permission, there is a number 2 associated with. And to execute, number 1. Okay, so using this 1, 2, and 4 number, like three numbers, we are going to grant different permissions with the combination of these. So if I want to give just execute permission, then the number would be just one. If I want to give write permission, then the number would change to two. If I want to give execute plus write permission, then the number is three, right? So 2 plus 3, 2 plus 1, 3, correct? Then for read, we have 4. So if I want to give read plus execute, then I can represent it with number 5. If I want read plus write, then I can represent it with number 6. And at last, if I want to give all three permissions, read, write, execute, then it is displayed or given by number 7. And here is the symbolic representation, how it changes. So please make a note of this. For read, we have number 4. To write, we have number 2. And to execute, we have number 4. Adding or subtracting these numbers, we are going to decide a set of permissions for a respective user. Everyone got my point?
Yes.
Okay.
Yeah.
I believe it is not too fast, right? If you guys have any questions with respect to any slide, please ask at that same time.
Yeah.
Yeah. Then we have the permission values in symbolic modes, okay, or symbolic methods. Everyone knows that it is represented by read, write, execute, that is RWX. So no need to think upon that or work on that. It is bare basic read, write, execute RWX. So this is the example how we are going to use octal values. Octal values that we see in 2 slides back. That is for read, the octal value is 4. For write, it is 2, and to execute, it is 1. So the command that we are going to use is chmod. It is used to do modifications. Okay. Now, if you can check the example number 1, we are setting a permission 700. Now, can anyone make a wild guess what does it mean?
All read, write, and execute together.
Yes, it is correct, partially.
Yeah.
Okay, so I'll tell you.
For
7 is for owner, maybe.
Correct.
yeah.
Exactly. So 7 permission, that is read, write, execute, is for the owner, and group and other have 0 permission, so they don't have any permission. They can't even read the file. Similarly, in the second example, we have 7 for owner, so all 3 permissions given to owner. Then we have 4. Now 4 represents read, right? So group has 4, so they can only read the files or directories. And others can't do anything. They have 0 permissions. Like that, in the third example and fourth example, we can check how we are going to set permissions using the octal values and chmod command. Now, similarly, using the symbolic notation that I talked earlier, that are read, write, execute, we can give permissions as well. Okay, for that, we are going to use the same command, that is chmod. The difference over here is that uh, there are 3 or multiple characters on the left hand side. Then we have 3 different types of operators in between them. And after that, on the left hand side, we have permissions, read, write, execute. So on the left hand side, I have to give for whom are these permissions for? Is it a user? Is it a group? Or is it others? I can check, I can give multiple people different permissions. So if I want to give user a permission, I'll just write you. If it is user, excuse me a minute. Okay, sorry. So if it is user, if I want to give permissions to user and group, so I will do UG. If I want to give permissions to all those 3, then I will go for UGO. Okay. Then we have an operator. It can be plus, minus, or equal to. Plus is for adding permissions. Minus is for removing permissions. and is equal to is for assigning permissions. Okay, and at last, on the right hand side, we have the permissions which are represented by RWX. And at the end, there is the file name or directory name, complete or relative path, depending upon your current location where you are right now in Linux system. Everyone good till here?
Yep.
Okay, so actually, this is the end of presentation. This all these slides have covered the complete chapter number 7. Now we will log into the console and practice because we have different options as well that we have to use and different techniques how we are going to give permissions. So Tejas, can you share your screen?
Yep.
Yeah.
Yep.
Now, Anya, can you tell Tejas what is the command to list down the permissions? How I can check permissions or
Is it the ln command?
correct? Tejas, can you just zoom into the command prompt and run the
Yes.
LL command?
Is it good?
Just move to root directory, slash directory, and then run LL command because there won't be any files in home directory of EC2 user.
Okay.
Yeah.
Yes. Is it visible?
Just move to slash directory. Do LL slash.
Yes.
Yeah. So just zoom in so it is visible to everyone easily. Yeah, that's good. Uh, Mansi, can you explain the permissions and type of file for bin directory?
So for bin directory,
Yeah.
we have read, write, and execute, all three happening together. It has one and uh,
The first character is L for
yeah,
linked file.
okay.
Yeah, that is a file type.
hmm
Go ahead.
Then we have RWX for showing like it's all the owner The group and other all three have read, write, and execute access or permission.
Correct. Now, Tejas, can you create a file by any name? Create it inside the home directory of root user. Move to home directory of root user. You're not audible. You're on mute.
Home directory of root user. I didn't get it.
That is slash root directory.
Slash root.
Yeah. See, check the slash directory. We just go above. Just scroll up.
Mm-hmm.
No, yeah. So here you can check that in the 19 directories, there is a root directory. This is the home directory for super user as well as root user. Both are same.
Okay, I
Yeah.
did went in home user actually. Home for
Yeah.
directory.
Yeah. Home directory is it is for local users.
Okay.
Slash home directory is the home directory for local users. So I want you
Okay.
to
So
move to
what?
slash root slash root.
Okay.
Yeah.
Okay.
Now
Now.
list down the yeah. Now list down the do long list using ll command.
Mm-hmm.
Okay. Prajot, can you tell me which command we are going to use to modify the permissions of these files?
chmod. Sorry,
Correct.
chmod.
Correct. Chmod. So now we will try to change the permissions of these files using symbolic method. Okay. So we are going to use ugo plus minus is equal to and read write execute. Okay.
Mm-hmm.
So now let's change the let's give root user execute permission. So how we can do that? For the file
CO
tejas.txt.
for the root user, right?
Yeah,
So
for the root user.
uh, what do we want to give access permission?
Execute permission.
Execute.
Yeah,
Okay. So
root.
u
Okay, chmod.
plus uh, execute x
U plus execute. Correct.
and the file name, right?
File name. Correct.
Okay.
Now
Yes.
check if the file permissions have been changed.
Yep.
Yeah. So as you can check, as soon matlab, as it has got the execute permission, it has changed the color code from white to
Okay. Green.
yeah fluorescent green. Correct. So the this color code represents executable files in your system.
Okay.
Yeah. So even if it is a txt file, it is an executable file. You can run. Correct. Now
Mm-hmm.
let's revoke the execute permission for owner.
For owner. Owner means root. No. Okay.
Yeah, owner means root. Like who is
Yeah.
the owner?
Okay.
Right, here we are talking about owner. Yeah. Right now it is
Okay.
root. It can be
Mm-hmm.
different as well.
Okay. So u minus x
and file name.
Yeah, the file name. Yes.
So it has returned to its normal color coding, that is white. Uh,
Yes.
Now let's do one thing. We will give read, write, execute permission to all three users, owner, group, and other.
Okay. So change mod U G and O
Yeah,
plus read, write, execute. Am I
correct,
correct?
correct.
Next G. Yes. Okay.
Now it has changed, right?
Yes.
Okay, now revoke three permission, a set of three permission, revoke, read, write, execute from group and other.
Okay. Change mod remove
Right.
from group
And other.
and other minus read, write, and execute. No?
Correct.
Execute. Next. Yep.
Uh, yeah. Now we have seen how we are going to use plus operator to add permissions, minus operator to remove or delete permissions. Now can anyone guess how we are going to, yeah, how we are going to use the assign operator, that is equal to? By using plus and minus, we are able to add and remove permissions, right? So why would we need is equal to operator? Think upon it. Avinash, Tejas, Mansi, Raju, can anyone tell me how we are going to use or why we are going to use is equal to operator? Because using plus and minus, we are getting our work done, right?
Hmm.
So, okay, I'll tell you guys. Sometimes there would be a need when I want to give permissions similar to one user. So if there is a root user, or sorry, if there is an owner who has read, write, execute permissions. Now, I'm not sure what are these permissions. I just want other users to have the same set of permissions that owner has. At that time, I will use is equal to, that is assign operator. Here, what I have to do is simply use chmod command. Then here I won't be giving any notation for read, write, execute. I will just say user permission, owner permissions is equal to other. So it will assign all the permissions that owner has to other user. So
Okay.
Tejas, can you give all the permissions that owner has to other user?
Okay. U is equal to let's give write permission.
No, no, no.
Then
U is equal to O.
oh, okay.
O. So what we are doing here is all the permissions that the owner has, we are assigning those set of permissions to other.
Okay.
Yeah.
Got it.
While using is equal to, we don't have to define if it is a read, write, or execute permission. Yeah.
Okay.
So it means like on the left, whatever we have, uh, that will dominate, and the right side will take over the.
Correct. Correct.
Yes.
A set of permissions on the left hand side of the operator will be assigned to the type of user on the left hand side of the operator. So
Yeah.
if you
Mm, actually entered.
what just happened?
I think
It removed all the permissions.
yes.
Okay. I made a mistake in that.
Okay.
It was opposite. So whatever the permissions on the right hand side will be assigned to left hand side.
Okay.
It's vice versa. So it has removed all the permissions from owner as well. So let's correct
Mm-hmm.
it. We will give read, write, execute permissions to owner.
Yes.
Okay, now let's try to give read, write, execute permission using the assign operator to other. So chmod O is equal to U.
Yep.
Let's check. Yeah, it has worked, right? So sorry guys, I made a mistake over here while explaining. But right hand side, like when it is U is equal O is equal to U, then all the permissions that or we are assigning O permissions that U has. So other will get permissions of owner. Now let's try and change the set of permissions using the octal values, in which we are going to use the numericals. That is 4, 2, 1. 4 is for read, 2 is for write, and 1 is to execute. And the structure is similar. We are going to use chmod command. So let's start now. They just run the chmod.
Yep.
And after that, I want to change the permissions of, I want to remove permissions from other. So it would be like 700, correct? 7 is
Yep.
for owner, 0 is for, first 0 is for group, and second 0 represents permissions for other users. So
Okay.
chmod 700 and the file name.
Okay.
Okay. So it has removed the permissions. Now,
Yes.
yeah. Now let's add a write permission for group and execute permission for other. So what that number would be,
For write it is 2,
correct?
and for no, I have not.
Execute it is 1. So it
Okay.
would be 721.
Okay. So we don't need to do plus and minus
No,
operators here. Okay.
no. We have to add these numbers in our mind and just give one respective number. So using
Okay.
the combination of 4, 2, and 1, we are going to create that number. Maximum it can be 7, minimum it can be 0.
Okay.
So now the permissions have been changed. Check.
Yes.
So
I
we
have
have a,
a question.
yeah, go ahead, Mansi.
So if the permission is already given and after that also we try to give the same permission, like we add the number and give it,
Yeah.
would it give us error or would it stay as it is?
No, it will stay as it is.
Okay.
Okay, let's try that. We'll check if it throws an error or it will stay as it. Let's try and give write permission to group. So already it is having write permissions. We will again try to assign write permission to it. It will simply, it won't throw an error. It will just display, it will just execute the command. So nothing is going to change. See, it haven't thrown any error and all the permissions are same. So earlier also when we were assigning seven, the read write execute permission to owner, multiple times we have seven here, right? At that time also it haven't thrown any error. It was simply executing it. So using we have seen how we are going to change permissions using symbolic values as well as numerical values.
Yes.
Now we will move ahead. Let me just check how much we have covered that day. Links of link. Okay. Now just make a note of these default permissions. Whenever a user creates a files or directories, there is a set of permissions assigned to it. Those are all default. After that, we can make changes inside them. We can modify the permissions. So whenever user creates a regular file, it's given permissions read, write, and read. So it is 664 by default. Uh, I will repeat it. Whenever a user creates a file, the permissions assigned to it are read, write, read. So the number is 664 by default. Now, whenever a directory is created or directory is created by any user, the set of permissions are read, write, execute, read, execute, read, execute. And the numerical number would be 755. Everyone good till here?
Yep.
Could you be able to repeat the permission for 664 or the
Yeah,
first one, the read write execute?
I'll do that. So for which one you're asking for file, right?
Yeah,
Regular file.
file,
Yeah.
yes.
So the permissions are read, write. Sorry, read. I'll repeat once again. Read. 664.
Okay, thank you.
Now these permissions are for local users, both for file and directory. When a root user creates a file, the permissions change for directory and file both. Okay. Now, whenever a root user creates a file, the permissions are 644. That is read.
It would be read and read, right?
Sorry. Yeah, read, write. Six, permissions. Okay. Yeah, read. Right. And for directory, it is 755. So execute, then read, execute. I have shared these values in the notes. You can refer to it. Now, like now, let's say who is the one behind these default values? Like who has said that root or standard user or local user, whenever he creates a directory or file, this is the set of permissions that he will get. Like what is that authority or what is that application inside feature inside Linux that is calculating these values? Like what are the default set of permissions? And is there any way I can bypass it. Like if I want to create a complete system for one user, for Tejas, okay, and I want to change the default permissions for whenever he creates files, I don't want these permissions. I want something different. So there is a concept of UMask for this. Okay. Now UMask stands for user mask. This is used to set the default permissions for new files and directories when they are created. It basically controls like which permissions are given and which permissions are not given. So if you can check for every file in Linux, there is a like now it is getting confusing, but just remember the default permission for any file is 666, whether it is created by root user, whether it is created by local user or anyone. But when we do the calculation using UMask, these are the like which we discussed earlier, those are the default permissions, right? So there is one value of UMask. We are subtracting that value from these 666 for file and 777 for directory. And after subtracting that UMask value, we are getting the default permissions which we want to set. Everything clear till here? I get like I believe I am not confusing you guys, okay? So now if in my system I set the UMask for at 022. Now whenever I create a file, what system will do is that if I create a file, then okay, it will check. File has permission 666. UMask is 022. Now I will subtract 022 from 666. Now what I'm getting is 644, and this would be the default permission for that file. Similarly, when I'm creating a new directory, the set of permissions is 777. And now as we discussed earlier, I want to change these default permissions to something different. And the UMask value, what I have set is 022. So now I have to subtract 022 from 777. And the answer comes down to 755. Everyone got my point? Okay, now there is a question. Now, how I can check what is the UMask right now set to? For that, we have a command which I have said multiple times, that is UMask only. So they just run the command UMask.
You must and
Only UMask.
okay.
We have to check what is the current UMask value.
Okay. 0022.
Yeah. Now just forget about the first zero. We are concerned with the second zero, the third, two, and fourth two. So right now the value is set to 02. Now let's think whenever I'm creating a file, I am giving a set of permissions to user that are read, write, and write. Exactly, correct. Now I want the user to have default permissions of read, read, write. So can anyone calculate what would be the UMask value for that? It is simple. From 666, subtract the set of permissions you want, that is read, write. So it is 000. Correct. Now, can we set these permissions? Let's check it. Now, let's change the umask value first. And to change it, we have to just use the command umask and the new number. So right now it is 000.
Should I enter?
Yeah, you can execute the command. Now check if it is the umask value has been changed or not using the umask command.
Yes.
Okay, now let's create a file by the name Enterprising AI. Correct. Now let's check what are the new set of default permissions assigned to Enterprising AI file using the ll command.
Right. Okay.
So yeah, so you can check. We wanted to have read, write permission to
Mm.
your owner, group, and other. And by default, it has got these permissions. So this is how we are going to use umask value to set a default set of permissions on different files and directories. Everybody clear till here?
Yes.
Okay. Now, this umask values differ from user to user. These
Mm-hmm.
can be different. Now, umask value for root user would be different, and for local user it would be different. Right now, what we have done is that we have changed the umask value for root user, as we have signed into the system using root credentials. Everyone getting my point?
Okay.
Now,
Yes.
whenever we want to change the umask value for local user, we have to log in using the credentials of local user and then change the value of umask. But every other step is same. Nothing changes.
Okay.
Yeah. And let me give you the default umask values for root and local user. For root, it is 022, and for local user, it is 002. So we have checked how we are going to change different permissions, how we are going to set default permissions, how we have to check what is the umask, how we are going to calculate it. Correct. Now there is a section of special permissions. I will just give you a brief overview about these special permissions. Tomorrow, we are going to discuss how we are going to assign these special permissions to different files and directories, how we are going to remove it, and why was the need to introduce these special permissions. Okay, so there are three types of special permissions, what we are going to discuss tomorrow. First is SUID, second is SGID, and the third one is sticky bit. Are you guys taking note?
Yes.
Okay, so I'll dictate slowly then. Done till here? So they have a numeric value associated with it. SUID has the numeric value 4, SGID has the numeric value 2, and sticky bit has the numeric value 1.
Can you please repeat?
Yeah. SUID has the numeric value 4, SGID has the numeric value 2 and sticky bit has the numeric value 1.
Sticky bit.
Sticky bit, STICKY BIT. Now let's try to understand what is SUID and what does it stand for. So SUID stands for Set User ID. Okay. Now what it does is whenever any user, this SUID is associated with different types of user, as it is mentioned in its name, Set User ID. It allows users to run file with file owner's permission. So for a limited period of time, we are giving that user the permission of the owner. Clear? Everyone clear what I meant to say? What is SUID?
Yes.
So it allows users to run files with the file owner's permission. That is the one line description of SUID. So whenever a user has this SUID permission, he can do multiple things. He can change the passwords. He can access different files of different users with respect to which user's permission he has. Okay. So we can think of an example of it like uh, in a group of people, there is one leader, right? And whenever he is absent or he is not present, there is the second person in charge. He automatically gets all those like permissions granted, what he can do and what he not, whenever the leader is not present. So this is why we use SUID, set user ID. Then we have SGID, simple set group ID. Now what it does is that there are different files, okay, and these files run with the group owner's permissions for specifically for files. So whenever there is SGID set up, the files would be run by the group owner's permissions. And for directory, it's different. For directories inherit the group ownership for new files. Clear, everyone? For SGID set group ID,
Yes.
what does it mean? Okay. We can think of an example. Let's try to make up an example of SGID. So whenever you must have created a shared folder, right, online somewhere for a group project or something. So that is an example of SGID. It is a shared folder and multiple users have access to it. Hello?
Yeah.
Yeah. And the last one is sticky bit. Now, this is only applicable to the file owner, and only the file owner can delete or modify files in a shared directory. So if Mansi has created a directory in Linux system, which we all users are, like everyone, like Tejas, Avinash, me, Prajot, Adnya, we everyone are using the files inside it. Now she has a fear of whether we will delete those files or we will like do something mischievous with it. So what she will do is she will add a sticky bit to it. So what it does is she has the access to delete the files inside that directory or modify them. We can just use them. That's why, for that reason, we are using sticky bit.
Okay.
Yeah. So in the 19 directories only, temp directory has sticky bit assigned to it. So there every user can add or create files, but the only creator of that file can delete it. So if you create a file inside it, you can only delete it. If Mansi creates, she can only delete. Yeah. Now I will show you how we are going to check if any of these special permissions are assigned to any file or not.
Yeah, it is not working actually. I'm
What happened?
I'm typing something, but I changed the network before. Maybe it is because of
Stuff.
Just reload.
yes,
Is it working?
yes, it is working.
Okay. Now, just long list the slash directory using root credentials. Okay. Check for temp directory.
Should I go into it?
No, just check for like here only.
Okay.
Read the row of temp directory. Can anyone find the difference? What is the difference in the set of permission it is having?
T.
T, correct. So T situated at the execute permission of other. So last permission, that is T. If it is T, then sticky bit is added onto that directory. Okay. Now let's create a file inside temp directory using EC2 user. Let the user be same, create a file. Just to don't okay.
Okay.
Okay. Yeah. Do touch slash temp slash AI.
AI.
AI. Okay. Now it will create a AI file inside temp directory. CD command didn't work earlier because CD temp. So there is no temp directory inside tilde. Tilde is the home directory of local user, right? That's why it didn't work. You have to give the complete path, absolute
Okay.
path. Yeah.
Okay.
Now it will create AI file inside temp. Execute it. Okay. Now change the user to root user. Okay. Now check the contents of temp directory.
Okay.
Can you
Yes.
check for a AI file? Okay. Now try to delete that file.
Mm, is it the correct command? RN?
Correct.
Remove regular empty file.
Yes. Y. Enter. Okay. Now let's check if it is removed or not. And I want you guys to tell me why is it removed? Even if it is having sticky bit assigned to it, so none other user can delete that file. How root is able to delete that file?
Maybe it was regular empty file. Empty file.
Because of the owner.
Correct. Correct.
Okay, so because of the owner, it
Because of the root user.
okay.
Because he is the only one. Even if EC2 user has created that file, he is the owner. root can delete it. So it doesn't apply to root. It is applicable to all other local users. So let's create one more user inside this system. Or if you guys want, we can finish the brief overview only and practice it tomorrow because it's already 9:32. Works? Hello?
Yeah.
Yeah.
Okay. Okay. So we can stop right now actually because again we have to create the directories and then set SGID, SUID to check how it is represented, like how I can check. But it is both SGID and SUID both are represented by S, small s, and for SUID, that S is situated on the execute permission of owner. So owner won't have read write X like RWX permission, it will have RWS. And for SGID, that similar S is situated on execute permission of group. So group won't have permission RWX, it will have RWS. That is the representation, how we have to check if any of these special permissions have been assigned to respective files or directories. So I believe we are good till here.
Yep.
Still, we have a lot to cover into permissions after this, uh, in which we will learn access control lists. We have to do a lot of practice into access control list, and then we have at last pseudo permissions that represent super user too. So these two concepts we have to learn tomorrow and practice. So I just want you guys to do a lot of practice on Linux command that we have learned till now. And one more thing, on Friday, we would be having one test. Along with that, we would be having introductory session in which I want you all guys to prepare introduction about yourself, what you are going to like, how you are going to introduce yourself in your next interview. So it should be of 2 to 3 minutes. We are going to time it. You have to speak for 2 to 3 minutes uninterrupted about yourself. So prepare that, make a script. If you need any help, connect with me. We can sit together or we can do group sessions as well. How we have to script an introduction, how we have to pitch it. So everything depends upon your introduction script, how you are going to pitch it to the interviewer, like the tone, the accent, the vocabulary which you are using, and the confidence. So this week we are working on introduction, and every Friday we are going to work on interview preparation as well, in which we would do introduction, then how we have to answer different types of questions related to experience, our education, our background, and then we will move on to technical questions about Linux. And as we complete each topic, we will do technical questions interview round of that respective tool stack. When we move on to EC AWS, then we will have question set of EC2 AWS VPC. Right now, it's just limited to Linux. I believe today's session was not too heavy and everyone enjoyed it. We have a lot of absence students today. Yeah. Anuja, Asami, Shweta, okay. 3 are not present today. That's fine. So that was it, guys, today. Let's wrap up. Thank you. Thank you for joining in.
Thank you so much for the session.
Thank you.
Yeah. Thank you.
Thank you.
Thank you.
Have a good
Yeah.
night.
And yeah, Mansi, please share your notes in the
Oh,
group.
sure.
Yeah. Yeah. Thank you.